So I will start with a short, like giving a short context to what Kotlin Multiplatform is. So if you look at the possibilities and the stacks, the tech stacks that we can use to create software, there are plenty of them. Mostly because there are different purposes of them, maybe some historical reasons. For example, a certain company is used to some particular stack and they are fine with this. Also, some companies like Apple create their own ecosystems because of certain reasons. Some of them are technical, some of them are political. Anyway, we have the state where you have like dozens of options, and the challenge becomes like the challenge is about sometimes is about sharing the knowledge, sharing the code, and for example, if you create an application which has a backend and some clients like Android, iOS, web, you find yourself creating similar pieces multiple times, and hiring people that know how to do this stuff for this particular platform. So today we will sort of talk about how Kotlin tackles this problem, and I will try to give you some context how it was attempted to be tackled in the past. So for sure, in the past, there were some approaches, and there still are, because Kotlin Multiplatform is still experimental. It's not well established in the industry. So the slogan of Java was about, writing once, running everywhere. It's true, because whenever you have this Java virtual machine, it just works. However, let's, for example, consider the web. There were times where applets were quite popular, and some great applications were created like this way, but somehow it didn't catch. I don't know why, actually. Maybe because there was a need to have a separate plugin. Well, that's the fact. It sort of got disbanded. When you take a look at the front end, and when some Java developer wants to enter the front end world, there was this approach with Google Web Toolkit, which compiles Java code into the JavaScript runtime. And Google Web Toolkit is also getting deprecated. I know it from my company. We used it and we still use it in our code base, but it sort of didn't catch up. It didn't catch the solution, and the new solutions are going into them more web-based and the classic approaches. From the other side, if you take a look at the front-end developers, they try to approach the backend using JavaScript runtime, so Node.js. But from the backend, from Java developers' perspective, it lacks the type safety. Even if you use TypeScript, it's still not this. Then, if we look at the mobile, cross-platform solutions like React Native, Flutter, Xamarin, they attempt to create some kind of layer of abstraction, which also creates some problems. It may play well for some uses, but there's still some friction because, for example, if some platform exposes a new feature, then these products have to cover that. If we consider going super duper cross-platform, then C and C++ would in theory work, especially with WebAssembly is approaching, but C++ is getting out of trend somehow. So are we done? Is it the place that we want to be and share code with these solutions? I don't know, but we will just show you how Kotlin approaches this problem. So you might think of this XKCD comic that says, okay, we have like plenty of standards. Let's think of some new that will cover everybody's use cases and introduce this. So Kotlin tries not to be this in this part. Let me tell you why. The goal is, as we probably all know, so to share some effort, some logic during the creation part. Also, the maintenance is easier because you don't have to maintain multiple code bases that do mostly the same. Also, knowledge sharing is a nice thing, because if you know how to solve a given problem, but if you don't know the platform, then you still need to know the platform. And if you would know the platform, then you are safe to solve the problem. And the previously mentioned solutions, for example, Xamarin or for example GWT, well, it's not that easy to access the underlying platform. So it's important to not get buried under this layer of abstraction. And what, in my opinion, is the biggest differentiator for Kotlin is it doesn't try to, reinvent every piece just to be on its way. It tries to embrace whatever exists for a given platform and expose it in an elegant way. So here I tried to somehow draw what Kotlin gives you when you take a look at a given target platform, and you see that it adds some parts, like it adds its own standard library, the language, of course, the Kotlin language. It reuses Gradle as the repository, and I mean the Maven as the repository, like standard, and Gradle as the build system, but it doesn't provide its own runtime. Just to give you a short example, I created some simple project using the IntelliJ wizard. Here you have 3 modules. The one contains the common Kotlin code that doesn't know about any target. So here I just coded some simple logic that does something strange with 2 words. And the other 2 modules are platform specific. So they are written in Kotlin, but they also have in their sort of class path the technology specific libraries. So you can, for example, see here in the JavaScript part that I can access the platform specific console.log function, but I can as well use the alias that Kotlin provides in this line 3. And also this is the part for Java server. And you can see that from these 2 files, the platform specific files, I can just use this platform agnostic function as if it was just, just Kotlin. This is like monolithic stuff. So this is really cool. And this is a demo. This logic runs in Java console and in the JavaScript console as well. Going with some more advanced examples. In the previous meeting of this user group, I presented my little project, a synthesizer written, which has all the synthesizing logic written in the common Kotlin, so it doesn't know about any platform, and this common Kotlin this code exposes only this interface of synthesizing a given song expressed as this DSL as a sequence or like array of floats, and then the platform specific code kicks in and either uses the web API to synthesize it or like the Java API, and this is what the 2 applications look like. So this is the JavaScript one, so some kind of nice front end using Material UI, and the regular Java CLI, and it plays the song as well. And going closer to the topic of Carlos, this is some simulator of a project that my father is working on. So this is a platform for people on wheelchairs, and I tried to simulate it using Corgi. So the code of the simulation doesn't know anything about any platform. And the moment when I chose where it should run is the moment of executing the Gradle task. So I can, for example, type run JVM or run JS, and this is the moment where Corgi compiles it to this given target, and it just magically runs. And so let's try to dig into some statistics that JetBrains collected about multi-platform in its latest survey. So here you can see that this technology is mostly used to share code between Android and iOS, but also there's the second bar which shows that library authors want to create like platform agnostic code as platform agnostic as possible. This would be probably Corgi. And some other interesting statistic is what kind of features are most like shareable in using this Kotlin Multiplatform. So you can see some data classes, mostly like data serialization, deserialization, platform agnostic. Also algorithms is pretty platform agnostic. Networking, well, I'm quite surprised because when I think about like calling some endpoints from Java and JavaScript, this is quite different. But maybe using some Ktor clients, maybe it's possible to make it platform agnostic. So you can find more details under this link. I highly recommend it to you, because it turns out that this piece of technology is not that experimental, and people actually use it in some cases in production. And as I said, this is an excerpt from the component stability for Kotlin, and Kotlin Multiplatform is still in alpha, so it's just one step after experimental. So it's the second step on the way to get stable. So it doesn't mean it shouldn't be used, but we can expect some rough edges here and there. So maybe in some company internal projects, it may be a great place to experiment with this. So that's actually all from my side. Now I would like to give the microphone to Carlos.
Really nice, Piotr.
Thanks. Okay.